data, quantitative on the left, qualitative on the right. Quantitative data is going to be divided into two types, categorical and numerical. And then categorical will be divided to nominal versus ordinal. And numerical is going to be continuous and discrete. Let's have a look at the meaning of each one by one. So categorical data, data whose values cannot be measured numerically. Okay. So how we are looking at a quantitative data that cannot be measured numerically? That's a bit weird, but it makes sense. Why? Because sometimes we have a particular category that's not based on quality, it's a fact. So female versus male, for example. And you can't say 5 for male, 3 for female, or 5 for female. No. So then we divide that to nominal, which is a descriptive one, but can be distinguished by classifying into sets or category, or ordinal or ranked, but which can be placed in a definite order. Meaning what? Moving to the next slide, have a look at this. So, yep, quantitative, we have categorical versus numerical. Categorical or qualitative one, you're looking at nominal, which is unordered categories which are mutually exclusive, such as male and female, a smoker or non-smoker. Ordinal ones are categories that are mutually exclusive, like minimum, moderate, severe, unbearable pain. So you have pain and you go to doctor, and doctor comes to you and say, are you in pain? And you say yes. So that's nominal, yes or no. But then they ask you a question which is ordinal, and they say, how would you describe that on a scale of 1 to 5? Or is your pain minimal, moderate, severe, or unbearable? And you would say it is severe, but I can bear it. I'm not rolling on the floor and shouting and crying. Then we have, in the quantitative numerical variable, we have two types of variable. One is pret, the other one is continuous. That's quite easy to understand. The discrete data has the whole numerical value and typically counts. If I ask you how many sister and brother you have, you would say 0 or 1 or 2 or 3 or 4 or 5 or whatever. You don't have 4.5 sister. I have 2.5 sister and brother. No. If I say, how many times you have been married, you would say 0, 1, 2, 3. But you can't say, well, 2.5 times, really? No, doesn't make sense. If I say, how many children do you have? You have 2, or you have 1, or you have none. How many times in the last 3 months you went to the cinema? You can't say 2.5 times. It's either 1 or 2 or 5 or 10 or 20 or 0. That's a discrete data. Continuous one can take any value with a range. Like what? How tall are you? I am 170 centimeters. But you could be 169. You could be 169.5. You could be 169.7. So it can be anything. It can be in millimeter and then decimal or anything. And again, that's the explanation here, basically what I explained. Here, look at that again. We're looking at discrete data. You have 5 kids. How many employees do you have? Employees do you have? I have 96 employees or workers. How many laptops do you have? How many mobile phones do you have? I have 3 laptops. I have 2 laptops. You don't have 1.5 mobile phone. You don't have 2.5 mobile laptops. You have either no laptop or 1 or 2 or 3 or 4 or 5, whatever. But continuous data, how heavy is your bag? Oh, it's 3.25 kilograms, but it could be 3.26 kilograms. How far is your work from home? Oh, it's so close. It's only 1.32 miles. It could be 1.33. How big is your fridge? It's 7.25 inches. I mean, that's too little. Obviously, it's not a fridge. How big is your, I don't know, how long is your hair? It's 7.25 inches. So that's the difference. There are the differences between discrete versus continuous data. Again, please, if I go fast or if you have a question, stop me. Don't be shy. I can see that Alina also joined us. Fantastic. Good. Here there's a slide that when it comes to descriptive statistics, you have few things, we call it central tendency measurement. This is a slide, this is a very, 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 very simplified slide. I am teaching statistics, I used to teach statistics and SPSS workshop because there is a software, we call it SPSS. Type it here, you can Google it. It's very, very good actually. It's a very lovely software. And then I teach a student that, you know, the formula for mode, for median, for mean, all of those things, the variance, and all of those things. It takes me quite a few hours, sometimes in, you know, a week, just to teach mode, median, and mean. Unfortunately, or fortunately, I don't know, in this slide and next slide, they're a bit very, very simplified. They just say this and there is no explanation, there is nothing. That's why, unfortunately, I'm not going to teach it to you. But the meaning is mode. Again, don't worry about it. I'm just going to quickly go through it. I've been teaching in a master's degree level in Birkbeck College and UCL. I've been involved in workshop. Again, if you want me to send you material and document, I have quite a lot, but I'm not going to go through it now because it's level 4 and it's going to confuse you. So mode is the frequency of appearance of something. So you would say, talk to people for 10 minutes and the number of how often this has been, you know, what's the concept of it, how often that has been occurred, 20 times, for example. So that's the mode, the number, the maximum. The median is the range between the minimum value and maximum value. So imagine you have a class of 8 students, and if the youngest one of you is 22, and if the oldest one of you are 32, the median is going to be basically 22 to 32 is going to be 10 years, the difference, and obviously it's going to be the 10 years. And the average, which is the mean, is going to be the average of age. So median is going to be 27 because you have a 22-year-old one and the old one is 32. So you get the between the maximum and minimum, you get the median. But that necessarily doesn't mean that it's going to be the average, because you might have 7 students in age 32 and only 1 student in age 22. So the mean might be 30. So that's the average. Again, we have dispersion measurement. That means the distribution of variables, the value measurement. So you might have quartiles, you might, based on a quarter, 1, 4. So you would say the first quartile is 25%, the second one 50%, the third one 75%, the last one is going to be 100%. Percentiles, based on the name, you can imagine, is based on the percentage. You can have maximum, minimum, range. You have a standard deviation. Again, you're looking at how deviated your values are from the mean. So is it in the age, for example, if your average is 27, so it's going to be 5. So between the minimum and maximum, the variance, the coefficient of variance, index number. Again, I'm not going to teach you this because this is only these slides and that's it. And it's very, this slide, I'm really surprised is here. It's just giving you a taste of the name of the tests, basically, to understand the inferential statistics. Okay, the previous one is descriptive statistics. So you're looking at the average, you're looking at the variance, you're looking at mode and mean and median, you're looking at average, but not necessarily you can generalize. Okay, in this class, maybe the average age is 27, but so what? I can't say the average age of all of the students in Regent's College is 27. No, Maybe it's just your class. Maybe you have somebody in age 40 in your class which is older. Maybe in other class. No, you can't generalize it. You cannot make an inference out of it. But remember, inferential statistics, you're talking about big samples based on the population, so you can make a conclusion. That's trickier because then you need to make this generalization and you need to find out about correlations. So if there is a significant association, you go with the test, we call it chi-square. I know they write it chi-square, but they really read it, you would say chi-square. Or Kramer's V or phi, or again, significant differences, we're looking at t-test and z-test and ANOVA. So they're quite sort of, and they're quite famous. A strength of relationships, you want to see, okay, there is a relationship, but how strong the relationship is. Is it really a strong relation? You're looking at the regression. So again, there are numbers, there are formulas. So you're looking at a rule of thumb. If the regression is 0.7, you would say there is a strong correlation between independent and dependent variable. If it's between 0.4 to 0.7, you would say moderate. If it's below that, again, that has different sorts of saying like RS. Again, I'm not going to bother you with that because that is not something that has been, but there are formulas, there are ways and things that you're looking at a table, you're looking at the p-value, which is a significant level to say, is there any correlation or not to the start? Then you're looking at the level of beta, then you adjust the beta. Forget about all of those. We are moving forward. We are looking at, here is the easy part for you guys, because it's just about the examples. So few things, you have to be good with your eyes here, because you're looking at analyzing the quality quantitatively. How can I do that? How I'm going to present my data right now? Because you analyze it, but you are going to simplify it to make it easier for people who they want to make these inferences and conclusions. So you have to make it easier. We have various sort of ways of doing it. There are names here and pictures in the following slides. One of them is contingency table. So there is a table, you're looking at your categories. So here, for example, on the bottom left corner, we have two color of taxi. One is in green color, the other one is in a blue color. And you want to look into their frequency of being observed, being looked at. And you can see that you stand somewhere for an hour, for example, and there are 85 blue taxis passing by and 15 green ones. So you would say 80% of the 85 taxis that they just passed by, they are blue, and the rest of them, 15%, whatever, they are green. So you're looking at it like that. These tables, they are contingency tables that we have. Some of you are familiar with bar chart or column chart. Again, we are looking at various sorts of examples. So we are looking at, you're looking at the top left corner, total demand for 3 products. So I can't quite read it, but yes, you would say which one has quite a small, I can't see it. Let's look at the green one on the top right corner. So we have Ecuador, we have Dominican Republic, Costa Rica, Bolivia, Argentina. We're looking at some level of data, and we would say, for example, Argentina has the lowest level of whatever the data is. And again, we are looking at here at the middle, which I can't read, it's again quite tiny, scores by team per season. So you're looking at Team Blue, they are doing so well, and then that was minimized in the third quarter, for example. So a little bit of a, it's basically the bar chart. Then you can present your data as a pie chart or donut chart. So pie chart, you can see that, for example, United Kingdom, the one at the middle, you can see that, blue is, administration, and too small, I can't read, unfortunately. Let's look at the one on the bottom right corner. So we have India, 12%. Imagine this level of COVID-19 or something. Germany, 15, Canada, 15, China, 10. So you present your data. If it's like there's a hole at the middle, it's going to be donut chart. If there is no hole at the middle of it, it's going to be a pie chart. So here we go. Then we have the line graph or area chart. Pretty simple. You have seen this before many times when you're writing your assignments and things. So you're looking at, you try very quickly, visually, you can see that. I mean, I'm looking at the one at the middle on the top, and there are 3 different products. It says product X, product Y, product Z in 3 colors. Product X is in blue, product Y is in yellow, and product Z is in purple. You're looking at level of sale on the left, and on the horizontal axis you have the time from January till December 2004. And you can see that product Y, which is in yellow color, is doing very quickly. You can see that the level of sale is going up. There is a level of drop in January, but that's normal because in January usually if kind of people stopped after Christmas, people don't spend that much money. Product blue went down and again picked up. Product Z, which is in purple color, never did very well, not doing well. So if you're a marketer, you probably don't want to think about that product that much. So that's it. Simplify visually, you know, right away you can analyze and interpret the data, make the interpretation of the data much easier. Then we have a box plot or a stock chart. So this one has more of a statistical data embedded in it. One would be the quarter, but in this case, the example is the percentile. So you can see the division, you know, the first percentile, second, third, and that's it. Or it can be quarter, or it can be basically give you some information about, you know, the division of the time that data has been considered. Also, you can look at the median in the basically the box plot. So it tells you again from 5th July, 6th July, 7th July, what happened basically to the data. So you're looking at that and it gives you some level of good information. You're looking at scatter plot here, and it can be multi-dimensional. It can be 2 variables. On the left we have, on the vertical axis we have wife's age, and on the horizontal axis we have husband's age. And I don't even need to come close to it to read it. And I'm looking at this from this distance, and as you can see, I mean, we're not talking about a massive big screen here. I can see that when the husband age is going up, the wife age is going up as well, meaning there is a correlation between the age of husbands and wives. The older the husbands, the wives are older too. That means people grew together older most of the time. Although we might have a few examples. I mean, there is, let me get my hand straight. If you're looking at the hand, I'm pointing at a particular data. The husband is 70-year-old. If you're looking at the hand I'm moving, the wife is slightly younger. She is around 55 when you're looking at the horizontal vertical axis. So this is a bit of a change here, and we are looking at this data. The husband is 53 around, but the wife is around 60 something. So there are outliers as well, a slightly discrepancy that you can notice here, but mainly visually I can see what's happening here. The one on the right is happening when we have 3 variables, because on the left we have correlation between female age, husband age, and wife age. On the left we have a 3rd variable here, which unfortunately I can't read it. It can be the age of children, for example, but then that's where you have a multi-dimensional scatter plot. Here we have the bubble chart. The bubble chart shows a correlation between variables, but also the size and the frequency. So if the bubble is bigger, we're talking about a bigger frequency than the smaller one here, or the pink here toward the left is going to be bigger, more frequency. Again, if you're looking at correlation between 2 variables, we have this one on the left, and it can be multidimensional when we're looking at more than 2 variables, which is 3 variables here. One of my favorites, it's a radar chart or a spider chart. So it gives you a good visual aid when you're looking at the data very, very quickly. So here on the left, imagine the question is the interest in the subject in Regent's University, in Regent's College. And then we have music. Imagine you have music subject, mathematics, arts, French language, and German language. And right away give you a kind of a visual aid. Mathematics is very, very popular, 80%. You're looking at German language, quite popular. And then you're looking at sort of music is probably more popular, and then arts and French language. This is when you have one particular sample for particular, it's one case that you're looking at. On the right side, you can see you have more than one cases that you're comparing and contrasting as well. So here we have, somehow we have Air Force KC-135 in green color, and we have Boeing KC-767, and we have Northrop KC-80. I can't read it properly, but yes, that's it. And you can see that there are quite a different sort of number of passengers, for example. You're looking at number of pilots. You're looking at the heaviness of the aircraft. You're looking at, area refueling, for example, maximum fuel load. And it feels like the blue one visually is doing so well because it's much better than any other aircraft here in this picture. And then we are looking at Boeing, which is doing quite well, quite good in payload in tons. And then you're looking at the green one, which is Air Force KC-195, not that good, especially quite weak toward the left of the spider chart, not doing so well. So give you right away a very quick visual aid of, okay, which airplane is better, and you have all of those variables on the outside, and it says from the point of heaviness and the number of pilots and number of passengers. It gives you kind of a, it could be, yes, the level of interest in Regent's College, Harrow, Regent's College, for example, in different campus. So you have it, you can put it in this one, and right away kind of give kind of visual aid to interpret the data. And then we have the map chart. I mean, that's the simple one, because from the point you can see there's a map here in front of you. The example we have here on the right side is the percentage of restaurants with online reviews based on leading online directories. So, yep, looking at US, and right away, again, from this distance, I can see that the west coast of United States, California perhaps, and I think it's Orange County. I don't know. I'm not good at that. But you can see that the West Coast, they are doing so well. There are quite a lot of number, 25% or more, 25% or more. If from the point of percentage in restaurant, they have the online reviews. And on the right of New York, again, there is one here. If you're looking at, I'm pointing at it right now, that's New York. And the yellow one, quite right, sort of at the middle. Yeah, they have not many online reviews here. But right away, you get a kind of ideas. If you're good with the states in the United States, right away, you should know. I mean, if I was American, I would probably know it very, very well. And then we are looking at word cloud. So this one, you're looking at when you want to represent the qualitative data quantifiably. So you want to turn a qualitative data to quantifiable or quantitative data, because that makes the data analysis and interpretation faster. That means, you're looking at customer satisfaction, and you would put it in a number, and you would say, okay, how satisfied you are with your product? That's a very qualitative question. I'm very, very satisfied because of this and that and that. But you say between 0 to 10, how satisfied you are with your product, and you would say 8. And imagine we have a sample of, I don't know, 2,000 people, and then you would combine that quantity, you turn that a qualitative question to quantitative question, then you would say, out of these 2,000 people, the level of satisfaction is 6.8, better than average. So it's very easy rather than just use the qualitative wording.